A very good morning, students, and welcome back to your maths class again. So in the last two classes we have been doing fractions, remember that? So what was fractions, children? Fraction is a part of a whole. Remember, if you take half of puri in the morning of the whole puri, then we can say that you have eaten 1/2 of the whole puri. Okay, so today what we are going to do is we are going to solve the exercise problems in your workbook. Okay, we will solve the exercise problems in your workbook, that is exercise 9.1, equivalent of fractions. Please take out your workbook and your copies and let us get solving. All right, so you can see that in your first question, if you notice, it is a multiple choice question, right? So in the first question, question number 1, it is written that the multiples of a number are obtained by dash 1, 2, 3 and so on. Okay. Do you remember, children, what a multiple of a number was? If I take a number 4, okay. So multiples of 4 would be 4 into 1 equals 4, 4 into 2 equals 8, 4 into 3 equals 12 and so on, right? And so on. Okay, so the first question, which is given that the multiples of a number are obtained by, in the blank, what will you say? The multiples of a question are obtained by multiplying it by 1, 2, 3 and so on. Okay. So question number 1 will be multiplying it by. Okay. You understand now why? Because multiples of a number for any number, suppose, are found by multiplying the number with 1, 2, 3 and so on. Okay. Alright. As such, your question number 1, the answer would be option B. Okay. Alright. If you look at question number 2, children, in question number 2, the factors of 7 and 1 are. So what are factors of a number, children? Factors of a number are numbers when divided by a given number, the number is exactly the same. Okay, when the numbers that divide a given number exactly is called a factor of a number, right? It is already given in your next question. Okay, so the factors of 7 and 1. 7 and 1, 7 and 1, they have only one factor, and that factor is 7 itself. Okay, so that will be your option A. Okay, that is your option A. In question number 3, if you see, the numerators that divide a given number exactly is called, the numbers that divide a given number exactly are called factors. Okay, why factors? We all know that 2 is a factor of 4, right, children? We know that 2 is a factor of 4. How do we know that? Because if you divide 2 by 4, you can always do it like that. Okay, if you divide 2 by 4, what will you get? You will get 2, right? So, in question number 3, the number that divides a given number exactly are called fractions. Okay, children? So, our 9.1, the recall multiple choice questions are done. Okay? So, let us go to question number 4. Let me rub this off and go to question number 4. In question number 4, what do you have? Again, it is a multiple choice question, and the question is to check if two fractions are equivalent. What do we do, children? The options are divide, equate, cross multiply and multiply. So in our last two classes, we have been doing it repeatedly, right? That if we have to check that two functions are equivalent or not, what do? We cross multiply them, right? So the answer is cross multiply. Okay, the answer is cross multiply. All right. So for question number 4, the option is C. All right. Now question number 5. In question number 5, which of the following is an equivalent fraction of half? Alright, we have a given fraction half, and we have to find which is an equivalent fraction of half. Let us take the first option. What do we have in the first option? In first option A, we have 2 by 4. Okay. If we cross multiply them, what will we get? It is also very evident that we can reduce it to half, right? But if we cross multiply them, we will get 1 into 4 equals 4 and 2 into 2 equals 4. Are they the same? They are the same, right, children? And since they are the same, we can say that 1 by 2 is an equivalent fraction of 2 by 4. So question number 5, the answer is A. Children, this is in page number 7. Okay, it is in page number 7 of 9.1 of your workbook. All right. Okay, this was your question number 5. Right? I hope you have noted it down in your workbooks only. So let us go with question number 6. All right, let us go with question number 6. In question number 6, you have to find the cross product of 2 by 3 and 4 by 5. Okay, so cross product is very easy, children. All you have to do is multiply the numerator of the first fraction with the denominator of the second fraction. Again, you have to multiply the denominator of the first fraction with the numerator of the second fraction. It's a very easy way to do as well. Just draw a x and wherever it points, multiply them together. So once you multiply them together, what do you have? The cross product is 2 into 5 and 4 into 3. Right, children? So where do you see 2 into 5 and 4 into 3? In option C, right? So option C is your answer. Okay. All right. Okay, children. Okay, now please turn your pages and go to page number 8. Okay. Please turn your books and go to page number 8. Page number 8. Page number 8. Okay. See question number 7. If the cross products are equal, then the given fractions, what are they called? This is a fill in the blanks question, right? We have been doing it over and over again, that if the cross products are equal to one another, the given fraction is called an equivalent fraction, right? We have been doing it over and over again, that if the two fractions are equal, they are called equivalent fraction. That is the name of our chapter only, right? Okay, so try to see the next question, children. 7. Then we have question number 8. The fractions that denote the same part of the whole. Fractions that denote the same part of the whole. Okay, you have to fill the blank with whole. We have been doing that, right? Because suppose, see, let us take two equivalent fractions, 1 by 2 and 2 by 4. Remember that we had taken a paper, divided into two parts and then shaded off one part. If I take the same rectangle, divide it into 4 parts and then shade off 2 parts, the shaded part are equal. So in equivalent fractions, we know that they represent the same part of the whole. Okay. So the fractions that denote the same part of the whole are called equivalent fractions. Are called equivalent fractions. Okay. All right. Okay. All right. Let us go to question number 10. With our filling the blanks questions are, there is another one left. Let us go to question number 9. Okay. In question number 9, what do we have? In question number 9, we have, in cross multiplication, we multiply the dash of a fraction by the denominator of the other. So what in cross multiplication, what do we do, children? We multiply the numerator of the first fraction with the denominator of the other. So the blank can be filled up with numerator. Okay, the blank can be filled with numerator. That is your question number 9. Okay. Question number 10, 11, 12, they are all very simple. We have all discussed them, but let us do them together. Okay. All right. So in question number 10, you have to see if 3 by 4 and 9 by 8 are equivalent. Okay. Very simple, children. All you have to do is cross multiply. Right. So after cross multiplying 3 into 8, what is 3 into 8? 8 into 3 is 24, right? And 9 into 4 is 36. Are they equal? They are not equal. Since the cross products are not equal, I can say the fractions are not equivalent. Okay, children. So since they are not equal, I can say that they are not equivalent. All right. Question number 11 is very interesting. It's a very different one. Okay. Question number 11. Please try question number 11. All right. It is very different. You have two cross products given. Okay. 2 into 3 is equal to 6, and 6 into 1 is equal to 6. You have to write two equivalent fractions from the given products. Okay. We know that if two fractions are equivalent, then the numerator of the first fraction multiplied and the denominator, alright, multiplied by the denominator of the other fraction. Okay. Denominator of the other fraction will be the same. So if 2 is the numerator of the first fraction, 3 will become the denominator of the second fraction. So let n1 be the numerator of the first fraction, d2 denominator of the second fraction. Okay. If this is so, then I can say that if 6 is the denominator of the first fraction, n will be the numerator of the second fraction. Okay. I am just assuming that. Then I can say that 2 by 6, right? Numerator of the first fraction divided by denominator of the second fraction is equal to numerator of the first fraction and denominator of the second fraction. Okay. So this cross product will also be denoted by this fraction, this pair of equivalent fraction. It is just one of the answers. Okay. There can be many different answers, whatever you assume. Okay. If you do it the other way around, okay, you can get another answer as well. This is one answer. You can get many other answers as well. If you take 3 as the numerator of the first fraction, 2 as the denominator of the second fraction, okay, that also you can do. Again, you can keep it as it is. You can put d as the denominator of the first fraction and 1 as the numerator of the second fraction. No, this is the numerator of the second fraction. Then what will you do? You will get 3 by 6 will be equal to 1 by 2. Okay, both of them are equivalent again. So there are many different answers that you can do. Okay, for question number 11, another answer. Alright, children. Okay. Alright, question number 12 are 5 by 15 and 2 by 6 equivalent. Very easy. We have done that many times. Alright, we had also done a few word problems as well, right? We had done a few word problems as well. So the other day we had done that. Let us try question number 19. Okay. Let us try question number 19. The others were discussed in the previous class. I hope you have watched those videos. Alright, let us try question number 19, which was not discussed. Alright. So in the first question you have Lalita plays tennis. Lalita, that is your part A. Lalita plays tennis for 2 by 26. Okay, sorry, 2 by 26 of the month. 2 by 26th of the month. Right? And she plays she plays chess for 1/13th of the month. So you have to see, you have to check that if the time she plays tennis and the time she plays chess are the same. What do you have to do? You have to see if these two fractions are equivalent. So write 2/26, 1/13, okay? And then do a cross product. So once you cross multiply them, what will you get? 2 into 13 is equal to 26. 26 into 1 is equal to 26. Are they the same? They are the same, okay? So I can say that Lalita plays same amount of time for both games. Okay, we can say that. All right. Now please look at question number B, children. If you look at question number B, it is slightly different. Okay. I hope you have noted it down in your copies. All right. So if you see question number B, 19B, it is slightly different. Smita sings 3 days a week, 3 days of a week, while Ranjan plays 15 days of a month. Do they spend the same amount of time singing? You can say that Smita plays 3 days a week. All right. She plays 3 days a week. Okay. So in a month, this is also a combined time problem. Okay. So in a month, how many days will she play? Because 1 week, okay, 1 week has 7 days, right? And 1 month has how many weeks, children? 1 month has 4 weeks. So in a month, she will play 3 into 4, that is your 12 days. Why am I multiplying 3 into 4? Because 1 month has 4 weeks. Okay. So 1 month has 4 weeks. So in a month, she will play for 12 days. Okay. So 1 month, how many days has 1 month have? 1 month has 30 days. Right, children? Since 1 month has 30 days and she plays for 12 days, the fraction of the month that Smita plays will be, how many days are there in a month? There are 30 days, right, children? And of those 30 days, how many days does she play? She plays for 12 days, okay? In this question, see children, the fraction is not given. You have to find the fraction of days that Smita plays in a month. So the first fraction is 12/30, okay? The question is not yet over. It is also given that Rajan sings for 15 days a month. Okay, so I have Rajan sings, oh it should be sings, alright. Rajan sings for 15 days a month. So the fraction 15 days, right? So the fraction that Rajan sings, so the fraction of the month that Rajan sings is 15/30, because there are 30 days a month and of that 15 days are the days that Rajan sings, okay? So now you have to, the question is, you have to see whether Smita and Rajan sing the same amount of time, okay? So we have to check that if 12/30 and 15/30 are equivalent. So how do we check that they are equivalent? How do I check that they are equivalent? You can check them by cross multiplying, right? You can always take 12 by 30 and 15 by 30, right? All we have to do is cross multiply them together. So once cross multiplying, what will you get? You will get 30 into 12 and 15 into 30. Okay, children? So 12 into 30 will be, so 12 into 30, you can always make a workspace, okay? You can always make a workspace and then multiply 30 with 12. So what do you get? Alright, so 12 into 30 is 360, right? And 15 into 30, if you multiply it just like that, you will get 450. Are they equal, children? They are not equal, right? Since they are not equal, I can say that Smita and Rajan do not spend the same amount of time singing. Okay, children? All right. So I hope this question is clear. It was slightly tricky. Why was it? Because here the fraction was not given. Okay, we had to first find the fraction of time that Smita sang. And then we have to find the fraction of time that Ranjan sang. And then we had to check whether those two fractions are equivalent. I hope it is clear to you, children. And if you still have any problem, please get back to me. Okay, I'll see you in the next